Hello, hello, Shagathon here. Welcome back to another coding stream. And today, here on the 31st of August 2022, local time is 1812. A little bit late. Sometimes it's hard getting home from work when you got that commute and all that. You got to eat dinner and stuff. But hey, we getting here. I didn't mute my phone. I didn't even pull up. I knew I was forgetting something. Didn't pull up my stream info here. But yeah, we in this. No UI. I haven't even had a chance to look at it yet, so no alarm. But I had an idea for today. I think it'd be a lot of fun. It's going to be using the using SDL2. So I've got a setup here, and I don't want to do the meme of like we're going to do a tutorial day over. Copy pasted that. We're going to do a tutorial today over this thing. Here's your tutorial. Copy paste this, and it's done. Like, I mean, that's not what I'm doing here. I'll explain. What have I done so far? Basically, not much of anything. I brought in the logger. I brought in anyhow for their errors, and I brought in SDL2. If we go down into our main here, there's a bunch of code, but really all I did is I initiated the logger. I even copied that hello world, or I left that hello world in there. I don't think I copied it. So we'll get rid of that. There are no prints, so nothing to replace with logs. And that's really it. I mean, I changed main to return the result with the anyhow error in it. And what is all this other stuff? Like I said, I haven't really done anything. So what this is, if we go step over to the browser real quick, if we go to the SDL2 crate, I would also advise if you're interested in SDL2, which we haven't even really talked about yet, but their GitHub has a lot of information for getting things set up, like this bundled feature and everything, and like it can be a little tricky to get it set up depending on your system. There are some code examples here as well. Let's see, depending on how you're going to be using SDL2, whether you're using OpenGL, or whether you're using Vulkan, you could do manual, or I think you could do Vulkan. You could do manual OpenGL calls. That's the one, yeah, that's the one I was thinking of. And we could also use Vulkan. So we can grab a raw window handle. There's a lot of cool stuff here. I think a lot of it should be on the docs as well. But I don't know. This is the main page of the docs. So this is actually what I've copied. Basically, I brought in these actually I basically just copied all this code inside of main, and anywhere it was complaining, I did my imports through the IDE. So this is their kind of demo boilerplate code that they've given us. So before I go into talking a little bit more about things, let's go ahead and take a look at what this code currently does, and then I'll describe what I'm planning on doing today. And yeah, it should be a little bit of fun. So if I do a cargo run, you see that right there. That's all it does. The only thing I changed, by the way, is I changed the title of the window to this here, Coding Stream 5 SDL2 Testing, and I changed the width to a 1080p window. That's it. Everything else is exactly as it was on that docs page that we just saw. So let's go ahead and talk about what SDL2 is before I explain what I'm going to do today. And we can kind of see a little bit about this here. Rust SDL2 is a library for taking the new SDL 2.0 libraries from Rust, or talking to the libraries, excuse me. So SDL2 is a separate thing from Rust. And what this is here is essentially a... actually, this may be a slightly different crate. Excuse me, it works, it's fine. This is actually what I grabbed the dependency from, so we might have to skip back and forth. I might have opened, it's all good either way. 0.35, I think this is right. Okay, sorry. Like I said, man, it's rough when you get back from work and you gotta like scramble. So SDL2 is a separate thing. It's not a Rust program, it's not a Rust library. It is C. So we see low-level C components. There may be some C++ involved as well. I'm not 100% sure. But typically, if you see people using SDL, they're going to be using C or C and or C++. So what they've done here is they've made wrappers in Rust, and they've tried to make them idiomatic and all that. So SDL itself is let's see. Let's get the full name. There it is. Simple Direct Media Layer. Let me just go to the Wikipedia and burn my cornea from the light theme here. But it is a cross-platform software development library designed to provide a hardware abstraction layer for computer multimedia hardware components. So they can use it to write high-performance computer games, other multimedia applications that run on many operating systems: Android, iOS, Linux, Mac, and Windows. I believe Factorio was originally written with SDL as the backend, and then eventually they wrote their own engine. So here we see the library is internally written in C, and possibly, depending on the target platform, C++ or Objective-C. Objective-C would be used on the Apple side of things. But yeah, SDL manages video, audio input devices, CD-ROM threads, shared object loading, networking, and timers. And then we could do OpenGL, Vulkan Metal, which is another Apple thing, and Direct3D11, which is essentially DirectX. So that's a lot stuff to just like throw at you real quick, but think of it as essentially a way to kind of build little games or whatever. It's not really a game engine, it's more of an abstraction layer over all the hardware and everything that you could use to kind of build an engine around. That's probably the best way I would describe it. So what do we have here? What's this little demo app that they provide on the documentation, and what can we do with it? So let's go ahead and break this down, and then I'll give what I'm planning on doing. So they make a window, and this thing here, we can actually see the inferred type as a window builder. So they're using essentially a builder pattern here, where this thing here returns a window builder, and then you can call functions on top of that window builder to mutate, to modify the window builder. And you can see here, this one's returning a mutable window builder. And then you could probably stack more functions here. You could say dot something else. I can make it a full screen. I could make it minimized, maximized. I could Vulkan, I could do whatever. And that's going to return another mutable window builder. So then you can keep stacking those functions on over and over. And once you have kind of thrown all the components that you want into your window there, you call .build on it, and that actually tries to give you a window. And then they're doing unwrap here, but can I do this? Will anyhow pick that up? Yeah, it's happy. Okay, so instead of unwrap, we're just gonna slap the question mark on there. That does the job too. So yeah, build just says, okay, all the things you initialized with these different function calls, like position centered, all of that gets applied into the window builder, and then build actually smushes it all together and creates whatever a window is. So we have a window type here. Can't really get any info on it for whatever reason, but we have a window type. Yeah, the shell of a window. You can set get and set many of the SDL window properties. However, you cannot directly access the pixels of the window. It needs to be converted to a canvas to access the rendering functions. So we'll look into the canvas and stuff as we go. So that's about all we need to know for that. We got a window. Next line, guess what? They're turning it into a canvas. So now we have this mutable canvas here, and as we just read, this is what we're actually able to do, like draw functions and stuff on. So if we want to make cool stuff on the screen, we need that canvas. We got a canvas now. So they're setting a draw color. They're using this color RGB here. And I'm guessing color is an enum. Actually, I don't need to create one. I could just mouse over it. It says struct. Okay. Then let's go to color and take a look at it. Oh, RGB is a function. Okay, that's why. RGB, yeah, it's a function. It's not a, I was thinking it was a variant, but no, that doesn't make sense because we wouldn't be seeing labels on all these. So excuse me, my mistake. But yeah, we can go to color. Oops. We can go back to color here, and we have 4 values: RGBA, red, green, blue, and alpha. Alpha channel is used for transparency. If you like that stuff, if you want that stuff. And they're basically initializing it with 2 values. So typically, if you're not familiar with the way colors, RGB colors work, it's 0 to 255. So if everything is 0, Like all three values are 0, then that's going to be black. If all three values are 255, that's going to be white. So basically, the higher the value goes, the more that color is included in whatever the final color is, right? So 0 red, 0 blue, and 255 green is just a pure green color, right? And if you mix green and blue, what is that? Yellow. If you mix red and blue, that's purple, right? I mean, you get it, right? And then whatever the different values are, like if you're, you don't have to do 255, you could put something like 100 and you get different variants, right? You can basically make most colors that you would ever care about. Like you don't really need to have more values than this in most cases. So this is plenty. You can be happy with this. And then clear is a way to set the, it clears the current, oh no, it's, yeah, that's it. It clears the current rendering. I was going to say it's a way to set, but it sounds weird saying it that way. Basically, when we set the draw color, that's the color that we're going to use for drawing rectangle lines or doing clear. So then we've set the color and we do clear. That actually takes the entire canvas that we have here and sets it to this color. So it's, whatever green and blue make, I forget. It's yellow, yeah. I'm bad with colors. Don't judge me. So that means we're setting the entire canvas to that color, and then present just like basically update. Yeah, it says there updates the screen with any rendering performed since the previous call. SDL's rendering functions operate on a back buffer, that is, calling a rendering function such as draw a line does not directly put a line on the screen, but updates the buffer. As soon as you as such, you compose your entire screen or scene and present the composed back buffer to the screen as a complete picture. So you set up, I want this line, that line, that line, that line, blah, blah, blah. And then you say present, and all of that happens. So then we have an event pump, which is essentially a freaky way to refer to like, it's a thread safe type that encapsulates SDL event pumping functions. So this is going to allow us to get events. You're going to have what you would basically call an event loop, which is, a common phrase for it, where you get some kind of events that are coming in. In this case, it's going to be things like window events. Imagine the windows being resized, minimized, maximized, closed. You're going to have other events like keyboard, mouse events, etc. So all of that is going to be handled by the event loop. So that comes from this SDL context, which I didn't mean to, but I accidentally I skipped past the context and all, and I went straight to the window. But we also have this SDL context, which just initializes the SDL library, and this must be called before using any other SDL function. So that's cool. Oh, that's not happy. Okay, yeah, we'll keep the unwrap. I don't want to deal with that. So here we're getting the video subsystem from the SDL context, and that's actually what we're making the window from. So I kind of just skipped past that. But that kind of makes sense. We have to get the video subsystem. We're initializing it, and obviously if we're dealing with video, if we're dealing with images, that kind of makes sense. So that one's actually, fairly straightforward. So, yeah, so the event pump comes from the SDL context. And then, yeah, at most one event pump is allowed to be alive. And yeah, that's about it. Okay. And then we define this I variable, and that's going to be used for something down here where we're setting the color. So if we run the program again, we could see that the color changes. So they're using that I variable to do that. We'll break that down a little bit. So now we have what's called a game loop. So if you're making a game, basically you want that game to run forever. That's the idea. If I am playing the game and I walk away, I pause it, I don't pause it, whatever, and I go take a nap. I go to the bathroom. I leave the house for a week. When I come back, I expect that the game will still be running unless there's been some catastrophic failure. So the way that's really achieved is with an infinite loop called a game loop, is typically what it's referred to. They call it running here. This is a label for the loop. So they've labeled the loop running, and down here they're allowed to say break running. Because normally breaks the loop that it's directly a part of, which would be this for loop here, the event pump. But they've basically said, no, if you press escape or you quit, which is actually like clicking the exit button or the X button on the window, if you do either of those, we're going to break the running loop, which is like the overall infinite game loop. So that's what they're using that label for, as a way to, instead of breaking out of the event loop, breaking out of the entire program, basically. So that's that. Then we have this I here, and all we're doing with that is we are incrementing I, but we're using a mod to clamp the value. So I is defined as a U8. It's being inferred as a U8, but it is a U8. And that's because it's actually being used in this RGB function, which expects the a U8 value. So we have an 8-bit unsigned, and that means it can go from 0 to 255. So by using a mod, the moment that I goes to 256, it actually clamps back down to 0, and then it counts back up to 255, and then instead of going to 256, back down to 0. So it's a way to just like keep that value, goes up, starts back over, goes up, starts back over. So it doesn't actually bounce. It doesn't count up and then count back down. It actually just goes all the way up and then immediately jolts back. See, and that's why you see the window, it gets to this point and then it immediately goes back to the blue color. Now you could make it kind of bounce back and forth. You could make it go, oh, and we hit 255. Now let's go back down to 0. Like actually, like decrease, decrement. You could do that, be a little smoother. But I mean, that's basically what they're doing here. So they're using this, and then they're applying this value in different ways to the draw color here. So they're saying red is just the I, B is 255 minus I, and then green is just hard coded at 64. So that's how we're getting like different colors happening every frame. And then clear, once again, just sets the whole thing to that color. And the event loop here is going to be really important. So basically, this poll iter, it's an iterator that will go through all of the events until there are no more events. So as long as there are events coming through, this loop will keep running, basically, unless we hit one of these events. And this is a bit of a weird structure here. This is only, all of this is a single match arm because there's an OR here. So we're saying we're matching on the event, whatever that event is, right? It's an iterator, so it just keeps going and just getting an event. We're naming it right here. And then if that event is a quit event, and this thing here is like, we don't care about any of that stuff. We're literally just saying like, throw it away. So right here, it says structure fields, we're missing timestamp. But by doing this ... notation, it doesn't care because we're saying we don't need those fields. So that's what we're doing here. We're getting the quit event, and then we're saying, or if it's a key down event, and then we get the key code structure field, and if that is some key code escape, this is a weird way of like kind of destructuring the struct in your match arm, and it took some time for me to like figure out how to use this the first time I messed with it, and I might struggle with it at some point again, but it's really powerful. So yeah, if you have a key down and that key down is an escape, and then there's other fields here, we could see if I do that, it says window ID, scan code, key mod, or key mode, or no, it's key mod, repeat. Like there's all these fields that are in here. The ... says, dude, I don't care. I don't want them. It's a bit like when you're assigning a variable and you prefix it with an underscore to say it's unused. But this is basically saying I don't want it. I don't even want to do that, right? That'd be a waste of typing. So just all I'm looking for is this key code field, and I want it to be an escape. So it's interesting. It's a bit of a cleaner way to break it down if you understand the syntax. And yeah, that's how we quit the program. I've kind of already explained that. And then any other event, we just do nothing. And then here, this comment was already here. Even though they call the loop here running, they do refer to it as a game loop here. So basically, you do any other stuff that you want to do with the program. And then the last things that happen is you do a present. And so basically, like, you drew some lines or something, and maybe you set a different color for the canvas. Like, you can do all this, whatever you want, right? Once you hit present, that's actually what's going to update it, right? Like we talked about earlier. And then this is going to be the weird one. This sleep here. So we have, also, I don't know why they do this. It works. I'm going to leave it, but I don't know why they put the double colon in front. I've never seen anyone else do that. So that's weird. This is going to be a little weird. It makes sense, but you got to understand their reasoning behind it. What they're doing is they're sleeping at the end of the loop for what is essentially 16.66666667 milliseconds. And what that is that's how long a frame lasts at 60 frames per second. So what this number is, they're using this 1 billion nanoseconds, which is 1 second, and they're dividing it by 60. Now, why would they do that instead of just say 1 second divided by 60? Because these are integer values. They're not floating points. So basically, if you said 1 divided by 60, you get nothing, right? Right, before you bounce, hello, Zach. Glad you stopped in, all right? I want to finish explaining this real quick. So, if you said 1 divided by 60, that's like, that doesn't work, right? It's an integer value, so you're not going to get that fractional value that you would want from like a floating point or something. So by taking a really large value and dividing it, it's going to be, what is 1 billion? Is it like 1 billion divided by 60? Is it like 17 million or something? It's probably, yeah, it should be million. So 1 billion divided by 60 is, 16,666,666. So basically, that many nanoseconds is a much more precise way to measure your frame time. There is one question I have, though, and I think they're doing this as a way to limit the frame rate, but necessarily this code is going to run slower than 60 frames per second by doing this, because that's exactly how much you need to sleep for 60 FPS. But then all the code in here takes time to run, so you're actually going to run a little bit slower. I don't think you'd want to do this in a real application. If you want to limit your frame, there are other ways to do that. So this is not the way you'd really want to do it in a proper application. So that's a breakdown of everything that's going on here. Before I start manipulating it and adding things and stuff. So, and it took a little bit, but I think it was worth, rather than just pasting something in and saying, this is it, right? Let's explain what we have here and try to understand it so that when I start manipulating things and changing things, it actually makes sense. Yeah, Zach, I don't know if Tusk will be around. Tusk has shown up the last couple times during coding streams, but things are still weird for Tusk, I guess. So he'll be back eventually, I'm sure. But yeah, I'm glad to see you here. So what am I going to do today then? What was all this in preparation for? I plan on doing 2 things. I wanted to do basically a little bit of physics, a little bit of simple physics. And this is all going to be like 2D basic kinematics. And the other thing I want to do is, it's going to be part of that. I want to do like a time step or like a delta time. So what we can basically do with that is decouple our physics from our frame rate. So we're using kind of a real measurement of time to determine how much should we simulate between each frame and simulating only what we actually need to simulate rather than tying it to our frame rate. And then, you know, if you're trying to play the game on a faster computer and the game runs too fast, you know, the physics break. We've seen that in like Bethesda games where if you unlock the frame rate on like Elder Scrolls 5, even Skyrim, if you unlock the frame rate and walk into like a house, all the stuff just starts like rattling on the shelves and starts flying around like the Exorcist or something. And that's because they didn't really separate the physics from the frame rate. So the game's not supposed to run that fast. Other games that have had issues by tying things to the frame rate is Dark Souls. Dark Souls 2 tied your weapon durability to the frame rate. So on console, it was running at 30 FPS. Every frame that the weapon spent in the enemy was dealing damage to the weapon. But when it ran twice as fast on PC, your weapons were degrading twice as fast. So that was a big issue, and you'd want to find a better way to do that. That's not really physics in that case, or it could be. You could consider it physics, but that's an example of like you don't really want to tie things to frame rate because you can have bad consequences. So, in terms of like any kind of physics simulation, you definitely don't want to tie it to frame rate because it just gets completely broken the moment your frame rate starts to change. So, although some really old games, though, for the record, older games, it does work fairly well if you can guarantee you're only ever playing at like certain frame rates. Like an old 2D platformer from the NES or something, it works pretty well to just tie the physics to the frame rate because you know what that hardware is, you know what's going to happen. But when you're getting to more modern games and frame rates are very variable, you definitely don't want to do that. And then if you're doing any kind of serious physics simulation, don't tie it to frame rate. In fact, there's that gets into a whole other thing. But let's not go down that rabbit hole. Let's actually get started doing something here. What I wanted to do is basically, it's been a while since I've used that SDL, so I'll probably stumble around a little bit. So do bear with me and forgive me a little bit on that. I am going to also make a couple of variables up here, maybe. Let's see. I'm going to say let what is this? What is this here? Come on. Oh. Okay, it is a U32. Okay. So width is 1920. Is it? No, what is the thing? Dude, I told you I'm gonna stumble around. Expected identifier, found keyword, let. Is this all I need to do? Oh yeah, you don't use let up here, excuse me. Okay. Okay, and it's 1080. There we are. Now I'm gonna swap these out. Okay. So we have width and height here. And I did that because I'm gonna reference them a little bit. And instead of having to hard code that over and over, it's nice to have a good static up here to reference. Constant, you know, it's not going to be changing or anything. So there we are. I'm also going to go ahead and make a struct. Or am I? Does SDL have a point? Can I find... It does have a rect point. Sounded like I said something else there, didn't it? So we'll use SDLs, but essentially the idea, what I was going to make here is struct point, and it would be x. Well, there's two ways you could do this, and we'll say u32. It doesn't matter, and y u32. So this is one way to do it. You have named variables or named members x and y. The other thing you could do, my point 2, u32, you can make a tuple struct here, because you really don't care so much about x and y names in this case. They don't really give you that much information, so you could just make a tuple struct. So there's a couple different ways you can do this. If we take a look here at the point here, close that. It's an SDL point. Oh, they're referencing like some kind of raw type here. So, yeah, but what we can see here is that we have this x and y value. So they basically did the standard, which makes sense because they're going to be dealing with like the C code. So C doesn't have that whole idea of like tuple structs and all that. So it makes sense that we're going to be dealing with like an x and y value. So before we start our loop and all that good stuff, I'm going to make a mutable point. We don't need to specify the type. And then it's missing. Actually, we might not want to use this. Yeah, I might want to just make my own. Raw is a private field. Yeah, that's not going to be fun to use. Okay. Raw is a private field. It's gross. So we're just going to say struct. If I can type struct point x. The thing I don't know is if they need to be U32 or something else, so we'll just go with that. And we'll say derive debug. And that's all we really need at the moment. So we're going to make a mutable point, and we're going to say x is width divided by 2, y is height divided by 2. It's unused variable, of course. And it's going to initially complain that it doesn't need to be mutable, but what I want to do is actually draw that point, which may be a little hard to see on the screen. So I might do something a little more with it right from the start. We'll see what it looks like. But basically, we're going to have a point right in the center of the screen, or about as close as you can get to it as possible. There are issues where, you know, dividing 1920 by 2, what is that? 960? Yeah, 960, so that kind of works. 1080 divided by 2 is 540, so that works. But there can be cases where you have like a number that doesn't divide very good. We shouldn't run into that with this. So that's going to be fine. All right, so what I want to do is simply draw the point. And how do we do that? Well, let's see, canvas dot, and we have all kinds of stuff here, but it looks like we actually have draw point. Draws a point on the current rendering target. Errors if drawing fails for any reason, like a driver failure. And here we go. And it actually wants a point type. And I just remembered something. We probably could have used that other point. So we're gonna just put this, and it's probably gonna be mad because it wants an SDL2 rect point. So let me try one more thing. SDL point equal SDL2 rect point default. No, new. They just control it with a new. Okay, so then this will be better. Yeah, I completely forgot to just check. Oops, it's a function, not a struct. So yeah, let's do that. Let's remove the point that I made because we're not going to use it after all. And now we do run a risk we're never going to have this happen on any window that we create. But because this is a U32, its max value is like 4 billion, whatever. And an I32 is like 2 billion. So you do run the risk of doing that typecast of what's the word? You're reducing the width of your data type essentially, or at least the max value of your data type. So if you had like a larger value than the 2 billion, that's going to give you some like really huge negative number or whatever in the I32. Definitely not what you probably want to see, but we're not going to have that because if we're making windows that are, you know, billions of pixels wide, like why are we doing that? That's a better question. Like even like a display port supports up to 16K displays, and like even a 16K display, you're not going to be doing that. That's still too many pixels. All right, so we're going to rename this to point now. All right, and it does not need to be mutable because we're not mutating it, but we're going to mutate it, so it's mutable. All right, cargo run. And yeah, we basically can't see it because it's just 1 pixel out of all of that. So let's try something a little bit more meaningful. Canvas.draw. We could draw a few other things. We could draw a rectangle. We could draw lines. Let's draw... There's a few ways we could do rectangles. So let's draw a rectangle. And we need to make a rect. Erect. So we're going to make a rectangle out of the point. So let's import that. And we'll say from center. And the width and height, the clamped and all that. So now we can pass the point in here. And we'll say it's 10 wide and 10 high. And we'll get rid of that draw point. And we should see something now. Oh, I know why we're not. Of course. I was missing one thing. And we talked about this earlier. So let's get back to this. And we're going to say set draw color. And we're going to make it white. We're going to draw a white point in here. So let's say 255, 255, 255. And there we are. So now we might actually see it. We do this or not? Nah. Well, that's fine. We'll be unwrapping a lot of presents today. Now I can actually see it. It might be a little harder to see on stream, especially because this gets... I'm seeing 1440p. You're seeing this on like a 1080p screen and it's getting squished down. So yeah, maybe, I don't know. But that's okay. Because we're going to swap it back to this other one here. And I think we need to put an unwrap on that. So this is basically going to draw a bit of a... Oh shit, that scared me. Oh man, thank you for the follow, I appreciate it. All right, so yeah, there we go. We have us a little rectangle there. I thought it was going to be filled. I think we need to do fill rect as well. So let's, instead of do draw rect, let's do a fill rect. Yeah, thank you for that follow. I appreciate it. Hope you're doing good today. It just came in and I was like, whoa, what does that sound? It's all good. It's been a long day. It's been a long day at work, okay? So this will be a little bit more visible. There we go. We got our little rectangle. Little simple little dude here. That's fun, right? But we actually want to do a little bit more with that. So, you know, right now it's complaining that this doesn't need to be mutable. So let's work a little bit on adding some control here. I think that'll make things a little bit more interesting. So what we're going to do here is basically take this match arm and do this for up, down, left, and, or we'll do WASD. So W, A, S, and D, and put our fat arrows in here. And then we'll put a little bit of code just to control that box. So I'm gonna say point dot. So if we're pressing W, we need the Y value. Returns the Y. Hold on, we should be able to. Is it a reference to Y? No, it's not a reference. Point.raw? No, I don't think so. Well, what does point.raw get me? How do I manipulate this thing? So this, I might go take a look at the docs. Because this only returns, this returns the value, but I don't think we're going to be modifying it. Because it's not a reference to the value. So if we did something like that, we're not actually, yeah, we're not going to get anything out of it. So let's take a look at the docs. Because it's been a while since I've used SDL. So let's figure out how we might use this. Can I find point? It's in rect, wherever rect is at. There's rect. And then we have point. Oh, it's an immutable point type consisting of X and Y. Okay. So I almost want to go back to my existing, where I made my own struct, and then we could derive, or not derive, but we could do an impl block for from my struct into this one. That way I can actually mutate it rather than repeatedly creating new ones. I might end up doing that, but we're gonna go with the quicker option for the moment. So I'm actually just gonna make a new point. It's gonna be terrible. Like, probably don't do this, but it's okay, right? It'll all be okay, trust me. Just trying to get something quick working. I'm not trying to spend too much time. So let's do point, whoops, I need to say point equal. Point.x and point.y plus 10. And we'll basically do this on all the others as well. So if we're pressing S, we're going down by 10. If we're pressing A, we're going left by 10. And I might have made a mistake. We'll see. I probably did. Graphics are weird, and I'll explain what I mean by that in a moment. Again, it's been a little bit since I've used SDL. So shockingly, my Y values may be reversed. Graphics are weird. Yep, I'm pressing W and I'm going down. If I press S, I'll go up. If I press A, I'll go over that way. That's all there is to it. But why is it reversed? Basically, in computer graphics, 0, 0 actually starts at the top left rather than the bottom left. So if you're used to, you know, graphs and stuff in algebra, you think of the bottom left as the origin, and then as you go to the right, the X value increases. As you go up, the Y value increases. The Y value is basically reversed in computer graphics, and you would start in the upper left, X goes to the right as it increases, and Y increases downward. And that can be thought of a lot by how you might visualize an array. I believe it's linked a lot to like linear algebra and stuff as well. But just think about how you might visualize an array. You typically would start at the upper left for an array and move right and move down. That's essentially what you're doing with graphics. So typically what you'll see is y increasing actually moves you down, and y decreasing moves you up. So it's weird, but it works. One thing to note right now is that this is actually not a very smooth motion. So if I press, what you saw there is now I'm getting some diagonal movement, but it's not very smooth. Like if I'm holding D right now, and then if I press S, I'm still holding D, but it's stopped moving. I can hold S and it works. I haven't let go of D yet. So there's some jankiness to the way it moves, but I am able to control this little square. That's all you need to know to make a game. I mean, in a way, it's true, because let's think about this. Let's think about what you could do with something as simple as what I've done here. By making this little guy movable, you can make the controls smoother. You could do some extra things to make them, feel better, but by being able to move something like this, you could keep track of variables. You have this guy's position. You could track something else, like I don't know. You could track like a consumable item, or like an item that if you touch you get points or something. You could make Snake. You could kind of make Snake out of this, especially if you made the character automatically move in a certain direction or whatever. Like, this is the most basic thing you need to really be able to build whatever you want from this. And you say it like that, it just sounds too simple, but it's true. So let's go ahead and take a quick detour, because I'm annoyed by creating new points every time. So let's take a detour and go back to what I was doing before. We're gonna call this point 2D. Whoops, why did I say let? Struct point 2D, and I'm gonna say X. And what are these? These are where is it? These are I32s. So I'm gonna go ahead and make mine I32s as well. And then I'm gonna say impl, what is it gonna be? I just did this the other night too. Let me think. From rect for point two. No. From point 2D for rect. Yeah, I had it backwards there. So we're gonna say E, and we're going to say rect new. No, we're gonna say, oh, I don't want to do rect. Excuse me. I want to do point. My bad. That's what was throwing me off. Okay, that's better. So then we're gonna say point new and p.x and p.y. So, okay, now we've got this little impl block here, which is defining how we convert a point 2D into a point. So I have my immutable struct here that's going to be a little bit easier to work with. So I'm actually going to swap this back out now for mine. So it's going to be point 2D, X, and Y. And why are you mad? Mismatch types is because of what I'm doing down here, yeah. Well, that's okay, because I'm gonna get rid of like all that. We're gonna do something better. Wait, why are you happy? Figure that out in a minute. So here we're gonna say point.x plus equal 10. And now instead of making a new point every time, it's gonna be a little bit cleaner. There we are. And here it's gonna be point.y plus equal 10. Point.x minus equal 10. end point dot y minus equal 10. Okay, use of value. Wait. Oh, right. That's fine. Yeah. So what we're going to do is we're going to say point dot into... Oh, wait, that's automatically happening, isn't it? Yeah. Type annotations needed label. Give me just a moment. See what's going on here. And then for type parameter P declared on the associated... Oh. Dot into... Can I do this here? Yeah. Thought I could just do an into here. We could do... do this. But yeah, it's complaining, so we want to change this to a reference. Because it's complaining that we moved it. So let's do ampersand point. And let's change this here from ampersand point to D. Now everything's happy. Okay, perfect. Now notice the cheeky thing here is that I don't have to do anything. I don't have to do this. It can actually just automatically infer that. So we're taking my point 2D and we're automatically essentially cast, maybe not the right word, but you could think of it almost like it's automatically casting into the point type that that we needed here. And the way we could see that's working here is there is a constraint on the type P here that says where P implements into point. So that's how you could take like any type that you want and actually just feed it in here just like I've done. So it's kind of cheeky, but it feels good. Like I could just use my own type now. I don't got to worry about theirs. So we're still able to move. Everything is fine. What I'm curious about doing is taking all of this and making something a little bit smoother. I've done this before, I'm sure. I think what you want to do here is it's a little less elegant, but you want to basically perform all of these every single time. So if you're pressing two keys, both of them get applied. So this can be a really long, ugly statement, but no, let's see. Event key down, it's not gonna be great. Okay. So here's our match arm. Wait, what did I do? Oh, hold on. That, I'm gonna close that and do that, right? Oh no, what have I done? Let me rewrite it. Event key down. Okay, then here we want this. There's where our code's gonna be. And we want key code, some code, dot dot. Okay, yeah, we've made everything happy. So now we're gonna have basically 4 conditionals in here. We're gonna say if code, be the best way to do it. Okay, that works, cool. if code equal key code A. Now bear with me here because I know this might not look as nice, but if this does what I expect it to, then we'll be happy. It should make the movement a little bit more smooth, and that's all I really care about right now. At least the control that I have over it. And if code equal WASD, okay. So for W, we do this. A, we do this. I could have probably massaged what I had already a little bit more easily. Okay, let's see if that does what I want it to. Not quite. We're still getting some canceling of the keys. So that's not really the best way to do it, unfortunately. Well, then I'm going to go back to the other method for now, and we might revisit this at some point. We're going to keep these as they were. Oh no, what have I broken? It's this. Okay, perfect. There we are. We got basic movement here. Pretty simple, pretty straightforward, right? I hope. So what we're going to do is we're going to add another event. Key down. I was thinking up in my head, but we're going to say key code, sum key code, space. And what I'm going to do here is I'm going to say jump. So things are going to get a little more interesting all of a sudden, because I'm going to start maintaining track of the idea of velocity, and we're going to do a little bit of basic kinematics here. So what am I going to do? Like, how am I going to hold that velocity? I could put it in the point. Maybe I will. It doesn't break any of my existing code. So what I could do is make a velocity struct and just say velocity 2D. And then we'll say right down here, struct velocity 2D. And it's going to have X velocity. Yeah, that's fine. And Y velocity. So I'll have some F32s for those floating points. Just for a little extra precision on their physics there, even though everything comes down to pixels on the screen, and we're only tracking these in pixels, in like integer pixels. There's no like really subpixels or whatever. This is kind of what you might consider subpixels though, because we might have something saying it's moving at 0.5. So it would take 2 frames to jump to the next pixel, because it'd go 0.5 one frame and then 0.5 another frame. Then now it's moved over by 1 pixel. Okay, so there's our velocity that we've now attached to the point 2D, and something's, oh yeah, because we're not giving it a velocity. So for this here, we're going to say velocity 2D, and we're going to say 0, and we're going to say 0, and it's going to be mad because those aren't floating points. Well, that one wasn't. But it's okay because I called it before it bitched at me. Alrighty, so here we have our point. It got a little more complex because we're maintaining a velocity with it. So what we're going to end up building is actually going to be a little bit less of a point. I mean, it's like a box, but this is going to be like something that you would see in a game engine where an entity component system or something would have these different components attached to an entity. So if it had physics, physics would come with things like a velocity. We're not really building an entity component system, but the idea is like this is attached to the thing, and you're then able to like filter out and get only certain components, get entities that like match certain filters and all that. You can do really powerful stuff with that. Here we're kind of building a hard-coded, very simple thing that we're just going to be able to work with. But yeah, that's about it for the velocity. And now we got to do some work with it. So the first thing we're going to do here is we're going to say physics. And what is the physics? Basically, you would process all the entities in the game that need to process physics. We only have one thing, so instead of doing any kind of loop or any kind of, whether it's parallel or oh my god, the word just slipped. It's okay. Not iterative. The word will come back to me. But whether it's parallel or not, you would do some kind of like loop or whatever and process physics for every entity in the game for every frame. We're only going to have to do that for one thing here. So we're basically going to say point dot x plus equal point dot velocity dot x as I32, point dot y plus equal point dot velocity dot y as I32. Oh, I said vel, that's right. Okay, and then if we're jumping, we can actually say point dot velocity dot y vel minus equal, I don't know, let's say 10.0. So if we jump, we now go up with the velocity of 10, which is basically going to be 10 pixels per, that's a lot, per frame. Let's say 0.5, and that's still going to be very fast. Oh, no, that's actually not too bad. So I press space, and now we're moving. Now, I could still, like, I could fight it. I could do that, but we're not changing the velocity. So it's actually stuck moving in that direction because of the way we've set that code up. We're not changing the velocity. Let's do this as, what was 10 gonna be like? Is it gonna go like off screen immediately? Almost. Let's do 1.0. I think 1.0 is probably a happy medium. If you can call it that. Dude, why did my phone just got like 4 notifications? What is happening? App I want to delete. Why has that one been pinging me the last couple of days? I should delete it. What is going on? Okay. If I hold S, it should come back down. Yeah, here we go. All right, so that's not really physics. I know I said physics, so this is where it's going to get a little more interesting. I want to do some basic kinematics and get into like a time step and some fun stuff there. So we're going to have to start adding some more components to the code here. So the first thing we want to do is we want to keep track of the time between frames. And what that means is it's going to be the concept of a delta time, whereas delta is generally used in math to refer to a change. So your delta time is how much time changed between the frames, how much time elapsed between the frames. So let's say SDL gave us a duration. Oh no, that's STD. Okay. I knew they gave us something because they did a duration down here. So we have a duration. Let's see, duration, or not duration, we want time instant. Instants are always guaranteed, barring platform bugs, to be no less than any previously measured instance when created. They're not guaranteed to be steady. Each tick of the underlying clock might not be the same length. That's not very good. The size of an instant. It should be fine though. An instant may jump forwards or experience time dilation, slow down or speed up, but it will never go backwards. I think that's actually still what we probably want to do. Distinct from the instant, this is not monotonic. It means you could save a file to the file system, then save another file to the file system, and the second file has a measurement earlier than the first. Yeah, that's because the system time might change. Yeah. So we probably do want to go with instant. Dude, my phone is blowing up and I don't know why. It's so annoying. Like, I just feel it like vibrates the whole desk. Yeah, that should be fine. So we'll get instant now. And we'll assign that to let mute now equal that. And then here at the start of the loop, we're going to say now equal this whole thing again. So that seems redundant. In fact, I can get rid of this because we never actually read that value. And then we're also going to say, before we do that, delta equal the same thing. No, it's going to be std time now, instant now, dot duration. Yeah, this is what we want. We want a duration since. So it returns the amount of time elapsed from another instant to this one. So, can I find, oh, right, I didn't say let. So let delta equal the difference between now and the last frame. So it may be confusing that I call that now. But basically it's the, oh yeah, that's right, I didn't initialize it. Yeah, let's just go ahead and put this up here, it's fine. That should keep it happy. All right. And in this case, like, it's not really going to be any different anyway. So there we go. So this is a very naive version of a delta time. This is very simple. This is not necessarily supposed to be what you would exactly put in a production game or something, but it should be enough to get us what we need here. So the idea here is that what we have is a duration of how much time passed from this point. We run through the entirety of the loop here, and then we take the delta, right? So even though it looks like these are right by each other, we're really measuring this after we get through the loop. And that delta is going to be what drives our physics. But what is our physics going to look like? Well, we need the equations of kinematics. Kinematics equations. I'm not joking. We need physics, and I never remember what they are. So you look them up. Oh God, I'm blind. What's going on, Tusk? Zach was here asking about you. What's going on with you, Tusk? Let's see. Kinematics for linear motion. This is what I need. That's not exactly the one that I need. It is not CBT. Why would you ever suggest that?
Ball stretcher.
All right, that's enough of that here. That doesn't belong on coding. That's not exactly what I need. I mean, I think I could derive it from that. What do these even mean? They don't tell me what these mean. I don't know what U is. Is that the height? It might be the height. Maybe it is. Let's see. Kinematics equations, height. How to calculate height and velocity from sciencing. Yeah, so we have velocity. So the velocity changes. That's one thing we're going to need. And yeah, I think that's going to be good. So we need velocity final is velocity initial plus gravity and time. So let's get that going in here. A tattoo of Vic Rattlehead. Be interesting. Okay, static. A. We'll say. When are you thinking about doing that? 9.8. I don't remember. 9.8 meters per second is good enough. If I could type. Meters per second squared. Acceleration due to gravity. And we basically want to do a little bit of physics here. So we want to change y position based on velocity. And then get velocity final based on time. Okay, that should be everything I need. So, oh god, it doesn't like that. All right, I'm gonna have to click back and forth a little bit. Initial velocity plus a times t. Okay, so point.velocity.y vel. Yeah, when are you thinking of doing that, Tusk? Equals initial velocity plus acceleration gravity times delta. Now I got to convert this to something. Dot as sex. Alrighty. So I'm not going to be changing X anytime soon. I will be changing Y. And I think this is going to be a naive implementation is going to be Y vel times delta as sex F32. A naive implementation would be something like this. And what happens if I jump now? Apparently nothing. I probably don't have enough initial... Ooh, wait a minute. One more thing. Is it minus equal? No. I might have to think about that. We'll see. I'll start that with 10. Not getting anything. I can still move around. Oh, we got it. We're moving. Why wasn't it working before? I know why. Because I hit the button a bunch and it was enough to overcome gravity. Wasn't it? So if we give it an initial velocity of 60, it moved a little bit. Yeah. There we go. So if I get an initial velocity of 150, it's moving on its own, and then it's actually slowing down. So this is pretty much already doing a lot of what I want it to. So I'm not touching anything, and we'll see what it does. Yeah, it comes to a bit of a stop. And if we watch it, we can actually see that it's going faster, or it's going faster as it starts, and then it slows down. But we're having a problem here in that it doesn't fall back down. So my calculation for the velocity doesn't seem to be doing exactly what I want it to. Probably... No, the acceleration due to gravity, even though I made a mistake, it's normally negative 9.8 meters per second. We want it to be positive because y is flipped in graphics. So there we go. So that's fine for the acceleration there. Times delta y velocity. Yeah, that's the initial y velocity plus that. Should it be plus or should it be minus? I don't think it'd be working if it was minus, would it? Yeah, no, we flipped gravity. What kind of Vic Rattlehead would you get, Tusk? Like what would it be doing, or what would it look like? So what we're gonna do here, we're going to put a log here and say I'm gonna derive debug for these. We are. And then here we're going to say velocity point.velocity. I want to see how the velocity changes, so we have some information here. Velocity is changing when it shouldn't. That's... Oh, now we're sinking. Okay, so yeah, we do have... Ooh, it's moving fast. So we do have something interesting going on here. But I also want to stop velocity at 0. So we'll say... Or I want to stop the point. Yeah. How would I do that? Basically 0 is the floor, so I don't want it to move. I mean, you could do a check basically and say add that velocity. Oh, hang on. Yeah, we can actually see though the physics are taking hold from the start of the program. So that's kind of what you'd expect. We can see here it's going upward, and then it's kind of halting, and that looks wrong. And the reason it's wrong is the reason it looks wrong is because we're doing this by pixel, right? Now we're falling back down. It's not working as well as I hoped it would. Let's take a look over here. Now that could be cool, Tusk. Also, what are you up to today? How you doing? Dude, this site is hurting my eyes. I'm serious. Yeah, the velocity should be 0 when it gets to the max. Solve for height. I think that's what I'm missing. 1/2. Yeah, okay, that's... I put some bullshit, and of course it doesn't make sense. So velocity... I don't know how to even get this. So initial velocity times time. Problem is, if I copy this, I'm going to copy it and bring it back in. It does that. So that's no good. plus 1/2 a times t squared. I think that's it. Okay, so now instead of me doing some bullshit naive stuff here, let's do it for real. I guess I'm doing okay. I'm tired. I'm always tired though. You know, that some things never change, right? Okay. So we'll say point.y equal. So we need point.velocity.y velocity times delta. Basically exactly what I have. Delta S sex and all that fun stuff. Plus 0.5 times acceleration gravity times delta S sex F32 dot, do we have power? Raises a number to an integer power to the power of 2. All right, so why is it mad? This should give us, we need all of this as an I-32, right? Okay, now let's take a look at what I get. Oh. It's decreasing. That's rather odd. That is rather odd. I feel like it's moving, but it's really hard to see. So we get the initial velocity times the time delta. Let me double check that browser over here. Plus 1/2 AT squared. Yeah, that should be it. It's weird, I've done this before too, and it's not been a problem. But of course, when I'm doing it live, it's a problem. Okay. My initial velocity is 0. And I think this for one. No? Why is my position not changing the way I expect it to? I'm gonna grab all of this. And I'm gonna plop it in here too, just to see what it gets me. I get the as I-32. Yeah. I think that's actually the problem, is that I'm using I-32. Yeah, of course that's the problem. I'm using I-32. That's just bizarre. Oops. There we go. I'm wondering why it's stopping at the top of the screen, though. There's some weird stuff going on there. Also, I responded, but I forgot to ask, why are you not sleeping? That's bad. Don't do that. Alright, so let's poke around a little bit more. Let's look at an example. Not inverse kinematics. I'm gonna look at an example here. Ah, that's not what I want. SDL. Physics and SDL. Let's take, oh God. It could be a problem with my time step as well. Okay, here, see, here we have gravity and stuff. So we have the delta time. Velocity plus equal delta time times gravity. That seems straightforward enough. And then their y is velocity times delta time, and their x is the same. Velocity times... What was the... Oh, don't do that. That's bad. Yeah, time since last update, and we get a float. Y velocity... They're doing this really simply, and it seems to be working all right for them. Delta time times gravity, which is about what I had before. So we could try this. I just don't see how that's gonna do anything. That's gonna... No, that makes sense. Yeah. I think there's just some weird stuff going on here with what I've done. Let's delete some of this and let's go back. I had something kind of working initially, but I tried to change it around too much and I kind of broke it. Yeah, so I'm going to put back this log here. Oh, not point dot y, point dot velocity. Okay. And it kind of hangs in the air, but then over time it starts falling and it'll start falling faster and faster. So I think the main issue is that it takes a while for the velocity to be enough to move it multiple pixels. But that just doesn't feel right. Like the velocity... Yeah, the delta should be pretty quick. Or what I'm trying to say is, like, if the velocity is 9.8, it should start moving almost right away. No. Yeah, okay. I understand why. It is. I feel so stupid too. It is what I said earlier. We do need floating points. All right, is everything happy? Not quite. Divided by. Actually, no, that's fine. Whoops, hang on. Expected F32 found I32. Oh no, that is fine. Yeah. The only other things that are making it mad is this. I understand now. I am an idiot sometimes. It is like basically the problem relates to the idea of like subpixels, if you will. We'll see what this looks like, but it's kind of better, but not really. Actually, no, I think that is much better. We're moving up like 100. Yeah. So the way you have to think about it is you have to look at this velocity here and saying we're moving up 20 pixels per frame basically, or per second, not per frame, per second. So right now it's saying we're moving about 100 pixels down per second. And you see it's getting faster and faster. Yeah. Okay. No, that is working. Okay. But might be able to do a little bit more with this. So I had a slightly different function here, a slightly different calculation here, and I want to go back to that and see how it works out. Point.y equal, and it was point.velocity y vel times delta as sex. What was it? Plus 0.5 times acceleration times delta as sex times pow or dot pow I 2. Does this get something a little more? Okay, no, now we're freaking out. We're going up there again. So it's a question of what that value. It's getting me like a value of 0. Yeah, it's getting me like a value of 0, and that's why it's clamped to the top of the screen. So you have to basically wait until. I almost need to see what this evaluates to, which is what I just did a minute ago. But even as an F32, it gets some weird numbers. Okay. Yeah, so we're converting that to an I32, and it's just 0, 0, 0, 0, 0. So if we actually do that again and we watch it, once that hits 1, I know it sucks to look at down there, but once it hits 1, it should start, yeah, it's now jittering a little bit. So this approach is not good. I think the simpler approach actually works better. But the thing is, the gravity is too light. So we'll say double gravity. So what is that? 19.6. Whoops. 19.6 meters per second squared. It's more like pixels at that point. So yeah, now we're falling a lot faster. Okay, and then what I'm going to do here for the jump, we're going to say minus equal acceleration gravity times 10.0. We're going to jump at 10 times gravity. Boom. So then it should take, actually, let's try something different. Let's try 4.0. If I'm understanding this correctly, if I've done this the way I hope I have, it should take about 4 seconds for us to reach the apex and then start falling. So then if we think like 1, 2, 3, 4, something. 1, 2, 3, 4, and then we start falling. So yeah, we jumped at about 4 times gravity and we got what we expected here. Then we're gonna say, see, if this is gonna be really sloppy, if point.y less than 0, less equals 0, 0, it's a float, it's okay. We'll get rid of the equal. It's less than 0.0, then point.y equals 0.0. Now, we're still going to be doing physics when we don't need to. But let's take a look at this. No. Oh, wait. That's not right. Excuse me. I need this value from up here. I'm treating the middle of the screen as 0. I actually want this value both times. And it's not less, it's greater. Perfect. So now it should, yeah, it rests there. And if that happens, point.velocity dot y, velocity equals 0.0. It doesn't need to keep falling, basically, if that happens. So we'll do that. And mostly it's going to be what I want it to be now. Okay. So if we look, we could see in the console where we're logging that it's not really changing the velocity. The velocity is basically, it's like pulling it down. It's trying to, and that's the effect of gravity on it. But it's stuck here because I told it it's not allowed to go any lower. Now, there's, I don't know if you call it bugs, but if I press down, I can't actually go down anymore, but I can go up. And we'll actually fall. I could do this and we'll actually fall, as you would expect. I can go left and right. That's all good. But I can't go below that point. I've essentially defined that as the ground. So let's add an extra thing here. We'll say, whoops, draw the point. We'll also then say canvas dot set draw color 0, 0, 0, canvas dot draw line, start, and we need 2 points. So we'll say point new, and we need to compute the height as like right here. Yeah, we need to compute the height from like right there. Except it's going to be, oh, whoops. X is 0. And the end is going to be this. Bear with me. Height divided by 2 plus not plus, yeah, plus 10. Also, that's not where that needs to be. Excuse me. That's what I want. Yeah, my bad. Also, and this needs to be color RGB. Just kind of hacking something together here. It's fun. Okay, it expected an I32. It found a U32. Height is a U32. Come on. And I will do this exact same thing, but we're gonna throw width as I32. If only I could make the line thick. Make it a thick old boy. I can. Dude, yeah, I can't see it. What is a thick line? It's a rectangle, right? So we can actually do canvas dot fill rect. Fill that rectum. And then we'll say rect. How do I want to do this? We'll say from center. And it's going to basically be the point, but it's going to be a little bit, it's going to be a little bit offset. So it's going to be point dot x, point dot y as I32 minus 10. I want to comment this out. Right, so that's the point, or that's the center, and then I need, why are you mad? Oh. Forgot to cast that. It expected a rect and it found a point. Oh, right. Fill rect. There we are. Okay. So then I want a width of, going from the center, yeah, the full width is fine. Width is I32, and the height is, ooh, what is it going to be? What did you expect? A U32 and you found an I32. Of course. Guess a negative width doesn't make sense. I think I might need to bump this down a little bit though. I think it's going to intersect. Oh, I did the wrong way. But actually, I think it's okay. I mean, we could flip physics there. Yeah, no, we're okay. Cool. All right, it's jank. We don't want to do that. Okay, let's let's make a rectangle. Let's just copy all this code. Let's just save this rectangle as the floor. And we'll hard code it out here because it's fine. I forgot. Oops. Actually, I think it's because I was doing it from the point, and I should have just done it like this. But let floor equal all that. Yeah, I did that from point. I should have just done this. Width and height. So now it's static, it's stationary. if I do that correctly. Or not. What did I not do correctly this time? Point new, we're gonna go. Oh. Yeah. Divided by 2. Divide by 2. Yeah. When I'm flipping between two different things here, it kind of gets a little wonky. There we are. Finally. Okay. Now I can move around. We got a floor. So when I fall, it actually looks correct. We could jump up. And it's going to take a little bit to fall because I just triple jumped. But watch that velocity there. We're negative. Now we're going positive. So that positive means we're actually starting to fall once again. We're falling at about 100 pixels per second. And here we go. And boom, we hit the floor. We stop moving. We're good. So, okay, this is it. This is kind of what I was going for. Is it pretty? No. Like, it could be a lot better, I'll say. There's something a little weird, and I think it has to do with this sleep. Let me get rid of this sleep. I think that's limiting us quite a bit. Maybe, maybe not. But I can't help but notice it still runs just fine without the sleep. Do a double jump. The thing is, we're now just running many, many more times per second. I don't know what my actual frame rate is, but yeah, we're running pretty fast. So we could actually track the delta times as well if we wanted. We could log those. But what the hell? Sure, there's like something on my arm. Okay, so we'll get rid of that draw line. We got a rectangle for the floor. We got that right there. Got that right there. We'll leave the sleep. So on the one hand, I feel like that's slowing me down, but on the other hand, it's not really, because if it were slowing me down, I mean, we're doing delta time, so it shouldn't matter how long the frames take. In fact, if I say divide that by 30, so now I'm running at like 30 FPS. It's no different. What are we moving at, like, what is my jump? Like 4 times gravity? So 1, 2, 3, 4, and then boom, there we go. So the idea is that we're jumping with a velocity that's 4 times that of the acceleration due to gravity. So it takes 4 seconds to pull us back down, or to at least negate our upward velocity and start pulling us back down. 1, 2, 3, 4. 1, 2, 3, 4. Like, that's obviously me counting aloud, so it's not super accurate. I could say run 10 frames per second. 1, 2, 3, 4. 1, 2, 3, 4. It still works as we would expect. I could even say, you know what? Run 2 frames per second. 1, 2, 3, 4. 1, 2, 3, 4. Like, it's not perfect with the way I'm counting it out loud, but you could see it's there, right? The physics are there. It's working exactly as you would expect in terms of, if you jump up with a velocity 4 times that of the acceleration due to gravity, rather in the opposite direction, then it should take you 4 seconds to start coming back down to reach your apex. So if our jump is only like 2 times that, then it should be a much quicker jump. But we'll get a lot less height as well. But there, we got like a little jump. So we could make like a little dude. I did a double jump by accident. Okay. So I mean, we got like a little jump. We can kind of scoot around a little bit. It's cool, nice and simple. What am I looking at? I don't know what like a normal jump for a human is. I don't know like how strong people usually jump, and it feels like we're falling a little slow. So there's some fine tuning to be done there. But the idea is here. The idea is solid in that we have a little bit of basic physics going on, and it does what you would expect. Give me one moment, by the way. Sorry. All right. Sorry about that. All right. So that's about it. It may seem simple, and I wasn't really trying to go for too much, if I'm being honest. That wasn't the point. I was trying to just demonstrate the way a couple of these things kind of work in tandem. But I will do log info delta. We'll log our delta. I don't know what that's going to show. And we'll get rid of this other log. We can see about how long it takes between frames. And wouldn't you know, there's actually something really interesting going on. Watch that. It's about 17.7, whatever. You can see it at the bottom, right? That's our delta, about 17.7 milliseconds. And now let's think about this. I already did the math earlier. 60 FPS. If we take 1,000, it's milliseconds, right? So we take 1,000 milliseconds divided by 60. What am I getting? Oh, I'm in the programmer calculator. Let me go to the regular calculator. It's 16.66666666 all the way down, right? So it's a little bit under 17 milliseconds. Notice we're taking a little over 17 here. But then watch this. My mouse is not in the window, but watch the left side right near the floor there. I'm going to move the mouse in, and now it went back down to 17. But as I move the mouse in and out, you see we're actually jumping up in the time. Or if I just take my mouse and move it in circles in the window, we're going 18 milliseconds as I'm moving my mouse around. And so what's actually happening is there are events as I'm moving my mouse. It's actually generating events in the window as you move your mouse in and out of the window, as you just do this. I could go press buttons that are, I'm not getting any noticeable difference, but I could press other buttons. Those are generating events, and that actually does take a toll on the event loop. So that is something to consider. But we're running pretty close to 60 FPS, just a little bit slow. I could try, how do I do this? No. Is it build? Oops. Cargo help. How do I do it? Cargo build. What I want to do is do an optimization flag. So let me look at that real quick. Cargo optimization build. There's a default optimization, optimizations trade-off. Let's take a look here. That's what I need. I don't know why I thought it was as simple as like a -O. So let's try this. Let's bring this over into our command and see if I can optimize this a little bit. So that's not going to make it happy. Okay. Found argument C, which wasn't expected or isn't valid in this context. Why not? Why not? I've done this before, but I never know the easiest way to do it. I don't want to build out like a profile if I can avoid that. Cargo, run, optimized. How to compile and run an optimized Rust program. Cargo run release. Oh, dude, it looks like you have to do that. That sucks. We could just start by trying release, though. But I wanted to specify the optimized flag. So notice we're having to do an entirely new build now because it is changing the optimization level. We're still seeing about 17 point something. So it didn't really change much in this case. And it's probably because of the sleep more than anything. If I get rid of that sleep, let's see what we get here with a run release. 9 point something. When I move my mouse in, I don't see any noticeable change. 9.7, 9.8. No, we'll keep the sleep out and we'll just do a cargo run. It's about the same. Yeah, we're not really seeing a difference. Okay. So yeah, I'm able to run that about 120 FPS, so that's cool. All right, it's fun to poke around here a little bit. We got these funky things I had going on. I don't know how I ended up down that rabbit hole because it just, something didn't feel right. But we are getting what we should expect to get. I think one of the issues is that we're zoomed out too far, basically. Let's try something here. Let me look up what the acceleration due to gravity is. Let me get a couple more decimal points. I want to try something interesting. Gravity of Earth. 9.81. That's it. It's been so long, okay? 9.81, but instead we're going to say 98.1. I have a method to this madness, so bear with me. And then we're going to... That's not terrible. Like that's not too bad for like a jump. I mean, this is us jumping at like the same speed as or the same acceleration. Yeah, that's not too bad. That's a quick like impulse, and then it takes about a second to come back. But that's still probably not super realistic, so maybe 0.8 would be a little closer to like a realistic jump. If even that. I don't know how long people stay in the air. I mean, it's a jump. It is what it is, right? So what am I doing here? What was the point of increasing gravity to 10 times that of the Earth? Basically, I feel that we're looking at a 1080p window and we're actually going at a per pixel level here. So we say meters here, but what we're actually doing is pixels. So when we're talking about 1,000 pixels in a direction, 10 pixels is like nothing. 9.8 pixels is nothing, right? So 100 pixels is a much more significant amount. So it's a little bit easier to see that difference. What you would really do then is have a camera that can like zoom in, and if you're a lot closer, the difference is you're no longer thinking about pixels, you're thinking about like 3D coordinates, and you could do some interesting stuff there, where your jump is actually based on distance rather than pixels. Because we're basing it on pixels and we're looking at, you know, 1,000 pixels, We're really looking at 1080 pixels. We only care about half of that since we're starting in the middle of the screen. But since we're looking at like hundreds of pixels, 9.8 is like nothing, right? So we still have the 4x jump here, but it comes back down a lot faster. So yeah, that's pretty cool. We could also do something where instead of doing, let's say, X and Y like this, we could change the velocity. We could, or yeah, instead of changing X directly, we could change X velocity and do a similar piece of code, but simulate friction. And we could say, I don't know what it would be, but we could just say acceleration due to friction. And you would basically apply a negative force. So what we're doing here is we're adding this acceleration gravity. You would basically do that same thing, but apply a negative acceleration compared to your x velocity, and then you tap the button and it slides the thing over, but then slows it down. So we can try to do something like that real quick. I've never done that one before, but let's try to do something like that. I think it'd be a lot of fun. So we'll call this static frictional coefficient F32 equals. See, I don't know what to put here. We're gonna say I've never tried this, so we're just gonna start it at 100 and see what happens and have some fun with it. So x velocity. So now we're no longer allowed to directly manipulate our x value here. We're gonna say dot velocity dot x vel, and we're gonna say minus equal, and I'm gonna basically mimic the gravity code as a simple one. This is not what you would do for friction. There is actually a coefficient of friction, and there are real physics formulas you would use for it. But we're gonna basically mimic this on the x axis and see what we get. Actually, let's see. Nah, we're good. I'm gonna do this at 2.0. That's what I'm gonna do. Okay. And then this one is gonna be, we're pressing D, we wanna go right. Okay. This is what we have here. And basically we're gonna end up with some, with some negative or positive velocity in the x direction on the x axis. And then down here, we're going to say change x position based on velocity and time, and do some code, and then get velocity final based on time. And I'm going to copy this, except I'm going to do it with the frictional coefficient. I'm going to change these to x's. Okay, and then up here we're going to do the actual code. So we're going to say point.x. Now this is the one where it could be interesting. So let me just try this, but I have a feeling we might run into an issue. So let me think about it for a moment. Actually, no, I think we'll be fine. So if x velocity is to the right, no, I think we need a negative sign, don't we? If x velocity is to the right, we have some positive number. No, that's fine. That's fine. Yeah. If x velocity is to the left, we have some negative number, and we'll just set x accordingly. It might be down here where the problem happens, because I think we'll just continuously keep accelerating in the wrong direction, in a certain direction, because we don't have anything stopping us. We don't have like a floor or anything. Yeah, see, we're just sliding. No, go the other way. Yeah, we're gonna keep sliding to the right because it's basically like gravity to the side now. We could also jump though, like I'm not I'm not touching anything. So that's cool, right? But what we need to do here is we need to do the negative frictional coefficient. Do we? No, no, no. We need x velocity equals x velocity minus that? Is that all we need? Except the problem I'm running into is we're not clamping it. So we're going to end up with the same problem. We're going to go left this time. So we need to clamp it. Let's see. What would the best way to do that be? If the velocity is close enough to zero, we just stop moving, basically, right? I mean, that's the general idea. Once the velocity gets small enough, we don't want to flip. That's an interesting question, actually. So what do we have on here as a float? We have exponents, we have fractional stuff, we have hypotenuse. There's got to be a way to do this. Reciprocal, yeah. I don't think rounding will do what I want. I was considering that. Again, I knew this was a naive approach. I've never tried that before. That's cool. I like that. That's a nice way to wrap something in an arc. Can I do dot arc? I can. Can't do mutex though. A lot of times if you wrap something in an arc, you have a mutex on it. Okay. Let me think. There's probably a really simple way to do this that I'm not thinking about. I am tired. I will say it again. The frictional coefficient is always in the opposite direction of the x velocity. Can I do something with that? X velocity. It's in the opposite direction. So if x velocity is negative, we want the frictional coefficient to be positive. Let's see. There were some functions on whether it's negative or not. So I could do something like this. If is negative. This is not a great way to do it though. At least I don't feel like it is. So then if it's negative, we want to add something here. Else we'll subtract. Yeah, I mean, I can see what this does. I don't think if we're gonna get like this jittering. Oh, maybe not. No, we're not jittering. Okay, cool. I made shitty friction. I like it. I made shitty friction. I mean, I've never tried that before, so that was fun to mess with. And now we got our jump. Actually, let me. So here's the. Okay, let's do one more thing. Let's do one more thing to make it better. If we're on the floor, do friction. If we're on the floor, do friction. So if point dot y this is where it gets tricky. And it gets tricky because I'm doing a no-no right now. But I think it's actually an okay no-no. So you don't normally want to do double equal checks on floating points because floating points are inaccurate. However, I explicitly set point.y to height as f32 divided by 2.0. And I am explicitly checking for that exact value. So any inaccuracy should be acceptable here. So we got friction, we got friction, we got friction. Wait for it to slow down, and then, yeah, we keep moving. Sweet. Let me reduce my jump, it's too much. It's like we can't even see it. All right, yeah, we keep moving, and then it should stop after it hits the... Oh, that's nice. I can even bump it faster. Is it gonna stop before it... almost. Oh, it's just on there, just the tip. Nice, okay. Yeah, all right, I think I made a fun little goofy thing here. Oh, too far. Is it gonna come back? There we go. So yeah, when we're like on the floor, it loses that speed really quickly. That's cool. I didn't plan on doing that, but it works out very well. And so here's actually the thing, like the jump probably could use some more work, but the friction looks pretty good to me. I can't really complain about that friction. It slides and comes to that gradual stop. You hit it a bunch, it takes a while to slow down. Yeah, that's probably acceptable. Okay, so there we go. Added extra things I wasn't planning on adding. And I'm gonna say we can no longer do W because we have a jump button, and we can no longer do S. So cargo build. Flippy's gonna hate this. Flippy's gonna be mad. What are you saying there? Actually, it's not as mad as I thought it would be. Manual implementation of an assign operation. You're saying plus equal. On what line is that? 117. Yeah, we could do plus equal. Unnecessary parentheses. Whippy's not as mad as I thought he would be. And we're still jumping. Oops. I keep hitting the arrow keys instead of WASD. Alright, we're going to jump super far. I can adjust in midair. Cool. Alrighty. So I had a little bit of a struggle there in the middle with the jump. And it was on me. It was my mistake for not recognizing that using fractional time, we're going to end up with a lot of issues if we're trying to use integers for our like our position. So everything's smoothed out once I recognized that and converted us over to F32s. So then that made the actual vertical acceleration work out. Horizontal acceleration was pretty easy, and the whole friction thing, like only doing it if we're on the floor, that's nice. I really like that, actually. That was that feels, it just feels nice. Like, does what you expect it to. It just slides a little bit and then slows down and stops. That's how friction works. Fun. Okay. Anything else? No. Let's recap this. I've been going a little longer than expected, as I always do, but let's recap this and just talk about what's going on here. The first thing I want to do is just say this is by no means what you would do in a real game, but it kind of is. So let's talk about the way you would really program a game. As long as it looks right, it is right. Because a player doesn't care if you're using real physics as long as the game looks right. Or I should also say feels right. As long as it feels right to play, physics don't really matter, if that makes sense. I mean, they do, because your physics have to at least feel convincing enough. They have to feel fun. They have to feel accurate, at least for the theme that you're going for in your game. But this is kind of what you would do if you wanted to put something that felt a little bit like real physics. And I mean, these are based off of, like, you know, some real kinematics equations. So, you know, it lines up with that. What we saw here is expected behavior, where if I jump up with an impulse, like if my velocity is 4 times that of the acceleration due to gravity, but in the opposite direction, it should take 4 seconds for that gravity to pull me back down, right? Because every second we're going to, you know, in this case, let's say it was 10. Let's say it was 10, and I went up with 40. Then in 1 second we're going to lose 10 meters per second. In another second we're going to lose another 10. Kind of. It's a little more complicated because we're not actually handling the whole squared part. Because what does end up happening is you actually end up falling faster over time. But we are getting that behavior. Just the way I'm explaining it is not necessarily encapsulating all of that behavior. But we are getting that behavior because we start moving faster initially, or rather we start initially moving really fast, and then we slow down and slow down and slow down, and then we come down and gain speed, just as you would expect. So we're getting that behavior. Like, it takes the same amount of time to go up as it does to come down. That's kind of what you expect. If we stop logging the delta real quick and switch the log back to that other one, we can notice something interesting if we can capture it. Oops, not that. We want to get that. We can notice something interesting if we can capture this all in the logs. It might be a little difficult, though. Where is that log? Did I delete it? I think I did. So let's go ahead and put a velocity log at the start of the physics. Log info, and then it's going to be this bad boy, point dot velocity. So at the start of this, we're going to jump, and there's a lot of stuff to go through. All right, we're going to close that. So we see 194. And when I first did my jump, we also see 194. So the start of the jump, we have that velocity of 194 straight up. And then we go. It keeps getting smaller. Then we hit 0, roughly. I mean, we didn't log it exactly at 0, but we hit 0, and then it gains and gains and gains and gains. And then it hits 194, and we're on the ground. So that's actually what's happening. It's exactly as you would expect. I mean, that's how physics works, right? So that's cool that we can actually see that in action and see the behavior that you would expect it to have. So that's cool. Was there something else? No, okay. So yeah, frictional coefficient, same idea as the acceleration due to gravity, except it's just working in a horizontal approach. This is just my own little bullshit way you just saw me cobble together, but it looks good. If I were playing a game and I slid something and it looked like that, I would be happy. Now, if it were a core game mechanic, I would, it would probably need fine tuning. But if you just kind of kicked something and it just slid like that and slowed down, dude, I don't think any player would be bothered by that, right? No player would say, oh my God, that wasn't exact. Those physics weren't perfect. Oh my God. They would never even think about it because it looks good enough. Once again, we'll run it and I'll just kick this thing over. It looks good enough. We could fine tune the number a little bit. We could make it a stronger coefficient, and we could make the initial velocity that I kick it with a little bit less or whatever, but it looks pretty good. If we were sliding something, that's a decent behavior. So I'm happy with that. So yeah, we basically have our point 2D with the velocity 2D tied to it. Guess what? You could extrapolate this into 3 dimensions. Exactly the same. You add a z coordinate, you add z velocity. That's really all there is to it. This little impl block here was cool and fun because by doing this, it made it where we can automatically just feed our point into that function, and we don't have to actually do any manual, like we don't have to do a dot into, we don't have to do any conversions down there. This function magically handled it all for us because they did the typing on that function very well by making sure that whatever you pass in implements into point. How do they? I'm sorry, I'm stumbling. I gotta see it again. Okay, yeah, it's into rect there, so we need into point. Yeah, so it is into, right. So the reason I was stumbling on that is because I didn't do into, I did from, but by doing the impl from, you also get a free into. It's the reciprocal of into. So by doing from, you get into for free, basically. That's what's going on there. And then we basically have all the stuff I went over before where we build up the SDL context, grab the video subsystem, use that to build out a window, which has our canvas, which is what we use to draw things. So we're drawing, we're setting the color, basically. We get an event pump, and then we set up our point. And our point is what we're using to, that's our little character, that's the little dude we're controlling. We use that point. I'm also making a floor, which is just that long ass rectangle. Again, you would definitely want something more pretty. This is not meant to be pretty, but this is just meant to show like some of the stuff, how you might do some of these things, which then you can extrapolate and do more with if you're making an actual game. So yeah, we make our floor, that big old rectangle, we make our point, and we're just kind of putting it at the center of the screen. That's all good. And we get now the current time. And then every time we go through the loop, we update that current time, but we also get the time since the last iteration. And what we're able to do with that is that delta time between iterations tells us how much physics to calculate. If we had like a really bad hiccup and it was like 2 seconds between frames, well, we know we have a velocity, and what would happen after 2 seconds? Like that velocity would go up some amount, but after 2 seconds, we can calculate what our new velocity should be. And if we do these equations correctly, which I haven't entirely done here, I do need to like really fix these equations. But if you do these equations correctly, the final position will not just be the velocity times some time. It'll actually take into account, like, what if you hit the apex and came back down? Like, you'll account for all that if you do the proper kinematics equations. I'll probably update this after I wrap up here. But I'd love to do it now, but I do got to go. I got to take care of a couple quick things before it gets too late. So yeah, we set all that up. That's how our deltas, all that work. I'm not gonna go over like, we just do some mod stuff here. We're just changing the color every frame, whatever. Not a big deal. If we press A or D, we knock the thing left or right. If we press space, we jump. And that's about it. I mean, we do the physics, which we just went over, so I'm not going to go over again. But it's basic kinematics kind of stuff, but not entirely. And it's all based on that delta time. So yeah, that's it. And then we just draw everything. That's it. So yeah, that was fun. Again, this is not meant to be like, this is how you make a game. This is the foundation that you would build from to make a game. You would take these building blocks and actually clean it up and make something better out of it. But this is the kind of knowledge you need to be able to make something better, right? Like, if you don't understand how the delta time stuff works, then you're probably going to be tying your physics to your frame rate or something. And then if your frame rate gets a hiccup, everything kind of breaks. So you start to run into problems there. So actually, wait, one consideration. No, I think, yeah, there's still an issue here. We need to do the better calculation for time. I kind of want to try and fix that. I really do want to fix that. Projectile motion, that's it. Got a Khan Academy article. Oh no, it won't load. Equations of kinematics in 2 dimensions. God, so why is everything just a plain white screen that's blinding? Placement. Yeah, so I mean, it's basically what I had before. Initial velocity. Yeah, initial velocity plus acceleration times time. No, that's fine. Okay, then whatever. Actually, yeah, I think that might work. I'm not gonna bother with it right now. Like I said, I do have to go. But yeah, so anyway, don't take this as like, don't take this code and build a game out of it. If you're watching this, take this code and learn from it so you can build something better out of it, so you can, you know, build a proper game. But really, you have the building blocks even from this to make a basic, simple game. It's just a matter of extrapolating from what's already here, right? You want to add more key inputs? Here you go. You want to draw something else? Well, like, yeah, those aren't great. You could draw something else. There's ways you could load in sprites and stuff. I don't know how to do that off the top of my head, but there are ways to draw like sprites and all that. So you can do that with SDL. You can load in textures. That's right. You could do textures. I have actually done some pretty cool stuff with SDL. One last thing before I am done here, I'll describe like I'll describe two things I've done in SDL, just to kind of explain the that this is a serious framework you could do a lot of interesting things with. First of all, again, Factorio started with SDL as the back end, and then I think they moved on to their own full engine, like that they built from the ground up. So that's already a pretty big endorsement. I have built Conway's Game of Life in SDL2 and Rust. It started out as me testing out a couple different things with like entity component systems, and it could be a fault of me not knowing enough about that particular framework, but I had a hard time filtering the way I wanted to. So performance was not great. I got it working, but performance was not great. I switched it to a more classical implementation, and performance was great. So I had like this fixed grid with Conway's Game of Life, which if you don't know, look it up. It's a cellular automata. It's like, just think about it as a grid, and each grid is a cell, and that cell is either, or each square on the grid is a cell. It's either alive or dead. And there's a set of rules that define whether a cell in the next frame is living or dead. So then you can create these cool patterns and stuff. That's the high level quick version. So I built that, but then I actually started building something even cooler out of it. It was basically it was Conway's Game of Life, but I had like a camera. You could zoom in and out. You could scroll it around, and the world was divided into chunks. And as you like scrolled the camera around, it would generate new chunks, and it was like an infinite world that it would just keep generating. I mean, infinite because eventually you're going to run out of memory or disk space or whatever, right? Obviously, but that was a lot of fun. I did that with SDL. The same thing we're seeing here. The other thing I did was I built out, just imagine like what you see if you open a thing like Netflix, where you have different categories of shows or different movies or whatever, and you have like images for each movie along with some information like a title and stuff. Using SDL, I built one of those. It called out to an API to get information on your categories, and it pulled in all the images and stuff, and it basically it would populate a screen like that, and then whichever one you had selected would be like zoomed in a little bit and provide some extra information. So that one was a lot of fun, and building it like this in SDL, it definitely took a bit of work, but it's the kind of thing where you figure out how to do something one time, and then you abstract it, and then you can do it as many times as you want. So it's a lot of fun. Those are two examples of things that I've done in SDL. Factorio, again, started in SDL, and it was in SDL for many years. So it's not like they switched 1 month into the project. I mean, it was already on Steam before they switched backends, as far as I understand. So it's the real deal. Don't overlook it. It's a great place to start if you're interested in making games. If you're trying to make a, AAA type game, first of all, don't. I mean, I'm joking. Have dreams, dream big, because that's where a lot of amazing things come from. But if you're trying to make something like that, probably just go with an existing engine like Unreal. But if you're interested in like the back end and like building something from scratch, this is a really good place to start, because it does handle some of the initial boilerplate, like the event pump and all that. A lot of this stuff you would have a lot more work to do if you were setting that up manually yourself. So SDL is a nice way to get access to a lot of freebies that you would have to spend a lot of time and effort getting working in if you were building it all from scratch. But then it does allow you to kind of build your own engine around SDL from scratch. So it's really powerful. It's really cool. All right. So yeah, I hope you enjoyed my rambling and this little goofy thing that I built. Again, it wasn't supposed to be too serious, but I had a lot of fun with it. I did stuff I didn't expect to do. The friction thing was not expected, so I had a lot of fun with that. And I really came up with this like last minute, as I was like, man, I don't have a UI ready, and I really don't feel like trying to figure that out on stream. So SDL, do some dumb physics stuff or whatever. It was fun. I had fun with it. So yeah, do all the cool follow stuff here on Twitch. Do all the cool stuff on YouTube. Like, subscribe, notification bell, all that good stuff. Comments, and let me know. Give me feedback. Like, I'm not perfect. I make mistakes. Constructive criticism, right? Tell me what I could do better. Give me suggestions. I do appreciate all that stuff. Like I said, I'm not perfect. That's how you learn, right? You share. You know, again, as long as it's constructive and it's like, oh, you could have done that thing better or this thing better. Again, I know this is not perfect already, and it's something I'll probably, rather the why stuff. It's something I'll probably look at again before I go to bed if I have time, because I want to get it fine tuned a little bit more. I think there's room to do that. But I mean, some of this is really jank. So yeah, definitely tell me better ways I could do things. I'm not claiming to be an expert by any means. I'm just sharing the knowledge that I have. If I were presenting this as a better tutorial, it would definitely be more research, not so off the top of my head. So take it for what it is, but definitely provide constructive criticism. I appreciate it. So anyway, until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
Oh no,